Right, the other type of battery tester we will be using is a carbon pile load tester. A carbon pile load tester will actually put a large amount of load on the battery and determine its output. The carbon pile load tester is a lot bigger than our electronic tester and also is a lot more invasive. It will as I say, put a load on the battery. It will also generate a large amount of heat. The unit itself is quite a lot bigger than a little electronic load tester, and the electronic load tester is just a little bit more versatile to carry in a service vehicle or the like. That's why they have superseded carbon pile load testers these days. But the carbon pile load tester is still a great tool to have when it comes to convincing, if you will, a customer that their battery requires replacement. The load tester we have is a Projector 500 amp unit. There are some basic safety procedures to follow. Ensure there's no sparks or open flames. Ensure you are wearing eye protection. Ensure that the vehicle and battery manufacturer's instructions are followed. That one's a bit vague. You would have to obviously research the vehicle or manufacturer's instructions to determine that, but that would involve things like the battery specification and the vehicle specifics with regards to testing the battery. Ensure that the vehicle load is off, so keys are off and out, all doors are shut. Ensure that the correct polarity is obtained, so positive to positive, negative to negative. Beware of moving engine parts. Obviously, if the engine is running, there's going to be moving parts, but to test the battery, our engine must be off and our key must be out of the vehicle. Note, carbon pile load testers produce a great amount of heat while the load is on. Do not apply the load for more than 20 seconds and allow time for the unit to cool down. When operating unit for the first time, it's normal for a small amount of smoke to develop as lubricants are used in the manufacturing and they will burn off. That's also just a general rule. If you smell a slight smell, usually there is some dust or the like sitting on the plates and they can release an interesting odour. Now it also has a sheet that's going to tell us the temperature coefficient for our testing range. Most of our testing will be done in the range of between, let's say, 10 and 25 degrees, which is a moderate temperature. It shouldn't have any effect on our battery at all. The remaining text at the bottom here is about charging system testing, which we will not be doing at this stage with this unit. So, to load test the battery, first of all, take the red positive clamp and connect it to the positive battery terminal or battery post. You can tell this one has a positive post, so it is a positive, and it is also the larger of the two. So, an adequate connection, clip it on, give it a wiggle. Connect the black clamp to the negative post. We can tell it's negative because it has a little negative symbol. It's also the smaller of the two. I would state that you need to ensure that the load tester is turned off. This dial seemingly will keep going. It does gain a bit of resistance towards the end, so spin it in the counterclockwise direction until you feel a slight change in the resistance and then stop. Apply the clamp to the battery post and give it a wiggle. The first thing we notice is that our DC volts rises, so off, nothing. As soon as we connect the negative terminal, our battery voltage rises, or our DC voltage rises. We can see that these sub lines are the ones, so as we go up to 12 plus 1, we've got 13. You can see there's a bit of a it's on the first little mark, so it's about 13.1, 13.09 volts. That is our resting battery voltage. If our battery voltage was below 10 volts, then our battery would need charging. If our battery is below 12 volts, we can see here on the little gauge that below 12 volts it requires charge. Below 12.8 is approximately what it would call low, and then below 12 is requiring charge. Anything lower than 10 volts is faulty. If your battery is below 10 volts, we're going to call it faulty. There is a little bit of nuance to that. If a battery has been sitting for a long period of time and is discharged, a decent charge cycle may bring that voltage back up. But if our vehicle drove into the workshop, turned off, and our battery voltage is now below 10 volts, that battery is faulty. You can safely assume that testing it will verify that. But also to adequately test it, you would have to get that voltage above 12 volts. So if our voltage will not rise above 10 volts, it's faulty, replace it. Alright, the first thing we need to do is determine the battery's cold cranking amps, or the battery's capacity. So stated on this battery, the CCA rating is 500. If we did not have a rating labeled on this battery, if there was no stickers, if it was an unknown battery, we could safely assume that it's the correct battery for the vehicle, and that way we could determine our battery specifications from our vehicle specifications. That's all the information we've got to go off. So if we have an unlabeled battery, then we'd have to make a couple of assumptions. Alright, so to adequately test this, we need to take our CCA rating of 500 and we need to divide it by 2. So we want half of the rating. So it is rated at 500, we want the rating of 250. We're going to turn our load dial clockwise until our current, our DC amps, comes up to 250, which is half of our CCA rating. It will stay there for 15 seconds before the buzzer sounds, alerting you that you can now reduce the load. In that time, you will monitor the battery voltage. If the battery voltage drops greater than 10 volts, then the battery is faulty. So we're going to wind the load on with the dial, watch our current meter come up. Takes a little bit to engage the plates, so you can wind away and then slow down as the needle comes up. We've wound it up to 250 amps, a little bit above, we can dial it back. Our voltage is staying nicely. There we go. So our voltage did not dip below 10 volts. It went to, I'm going to say, 10.9, looking at that scale. That tells us that given the load rating of this battery and the calculation of half that CCA rating for the adequate amount of time, that this battery is good. If the needle dropped below or into that red range, we would safely assume that the battery is faulty and advise the customer. There are a couple of different temperature degrees in here. If we were testing, say, -1, -18 degrees, it gives you a little bit more nuance within that range, because a cold battery has less output. So you can safely assume that there's a little bit less capacity because of the temperature, but given the temperature of our climate, we're always going to be looking at that highest range. Alright, that completes our how to use a load tester.